Whenever huge tectonic events happen, just like volcanic eruption, earthquakes, or explosions happen, just like nuclear explosions, they will all create some kind of energy that is really strong enough, and the energy that will travel will always become seismic waves. All of those seismic activity are very strong, and then as they occur, they will create huge amounts of energy, and those energies don't just focus on one area, they all will travel. Okay, and since those are all events that are happening in the earth, they will travel through the entire earth, through all of the layers, in the form of seismic waves. Look at it this way. Whenever I talk, the source of energy will be my throat. My throat creates energy. The energy travels to my mouth. My mouth emits the energy and it transfers it through the air. And as the energy goes to your ear, the sound waves are the source of energy, then you can hear me. So again, my throat creates energy. The energy travels in the form of sound waves. And when the sound waves reach your ear, that is when you can hear me. For seismic waves, let's take for example this fault line over here. Okay, we all know that earthquakes are caused by sudden movements of faults. Let's say for example this here is a certain fault, and then the faults are slipping this way. Okay, when the faults suddenly slip, the point where the slip happens, of course we all know this as the focus of the earthquake. Okay? We all know this as the focus of the earthquake. The focus is going to be the source of the energy, just like how my throat is going to be the source of sound waves. Okay. Now, coming from the focus of the fault of the earthquake, that is where the energy will come from. That is where the biggest amount of energy is coming from. From the focus of the earthquake, that is where our seismic waves will be coming from. Okay, so let's say for example the lines, the curves that I am drawing are going to be the seismic waves. A good thing also to take note is that seismic waves don't just travel again to this fault, but they travel through the entire earth. So let me just create a perfect circle over here. Let's draw the layers of the earth. You have the inner core, outer core, this is the mantle, and then let's say this here is going to be the crust. Earthquakes only happen at the surface of the earth, or as we all know as the crust, where the faults are. That's where the faults are going to slip. Let's say a fault has slipped over here, over this point, over here. That is where the energy is going to come from. Again, the focus is going to be the source of our seismic waves. So, seismic waves are going to travel from the source, and then the energy radiates or travels through the entire earth. Now, as what you've already known, there's going to be two types of seismic waves. Okay, so let me just draw a tree chart for that. So, seismic waves. This is how energy travels from the focus of an earthquake, or sometimes from a volcanic eruption, or through an explosion. There will be two types. We have body waves. Sir, ano yung body waves? Body waves are the type of seismic waves that are going to travel through the interior of the earth, that travels through all of the layers of the earth, through the mantle, through the outer core, through the inner core. And these are the types of seismic waves that can be detected from the other side of the earth. So let's say that let's have a scientist over here, And then there's a scientist also over here. If a scientist has a seismograph at the opposite side of where the earthquake happened, he will be able to detect the body waves that come from the other side of the earth. Okay? And then the second type of seismic waves are the type of seismic waves that just travel on the surface of the earth. We call them, of course, surface waves. These are the type of seismic waves that you and I experience whenever there is an earthquake. Okay, now in Davao City, an earthquake happened last year. It shook a lot of cities, it shook a lot of buildings. There were a lot of clips raging on the internet that caused a lot of mayhem. So there's participation here. You can see the camera moving. Let's see other videos that have been produced over here. Also over here. At a certain church. Okay. Yeah. The surface waves are the type of seismic waves that we feel the most because these are the types of waves that travel through the surface of the earth. So let's just go back to our previous image over here. There. Surface waves are the ones that travel through the surface of the earth. Okay? If body waves are the ones that travel through the interior of the earth, okay? Surface waves is the one that travel at the surface. And this here are the types of seismic waves that we feel the most. So the most of the shaking that we feel, the side to side motion, the up and down motion, the rolling motion that we feel during an earthquake comes from surface waves. Now, these two types of waves, or these are the main types of seismic waves, they all have different types of seismic waves. So let's go first with body waves. Again, body waves are the ones that form at the interior of the earth. There will be two types. We have P waves and we're going to have S waves. So let's differentiate them right now. Okay, P waves, P means primary. Just write it down. Primary. So these are going to be primary waves, and S waves will mean secondary. Primary waves, they are called primary waves because they are the first type of seismic waves that are recorded at seismographs. Seismographs are instruments that record earthquakes and seismic waves. So these are the first type of seismic waves that travel. Primary waves are the first type of seismic waves that reach seismographs or instruments that record seismic waves. Okay? Since they are the first types of seismic waves that get detected by a seismograph, it means that they are the ones that have the fastest speed. And because when an earthquake happens, they're the first ones that get detected by a seismic wave, by a seismograph, which then means they're the fastest ones among all of the seismic waves. Another thing to take note is that P waves are compressional waves. Sir, what does a compressional wave mean? It means that they move the ground, they compress the ground forward and backward. Okay, forward and backward. We'll see a few animations of that later. The second type of body wave is going to be secondary waves or S waves. These are the second type of seismic waves that will get detected by a seismograph. Another thing to take note is that, of course, they are the second fastest type of seismic waves, and in contrast to P waves, these are transverse waves. So this is how a transverse waves look like. There. Something like that. For compressional waves, they will move the material forward and backward. So just like that. If you would have seen an accordion, I'll just write that here, accordion. Okay, yung ginaganon good. An accordion. That is how P waves will move the ground. For S waves, they move the ground like this. Up and down motion. Okay? Just like this. Credits to this website. This here is how a P wave will move the ground. See? Forward and backward. One more time. Forward and backward. So as what you can see, okay, if this is the source of the energy travels like this. Follow the mouse, like that. The rocks here are being moved forward and backward. And the rocks are also being compressed. That's why it's called compressional wave. Now if we were to look at an S wave, it looks like an S. This is transverse motion, or the up and down kind of motion, just like the general wave that you are going to have. Now since these are body waves, this here is what happens through the interior of the earth when body waves pass by them. So, from the focus of an earthquake, the source of our energy, when they travel through the interior of the earth, first will be the P waves, so compressional waves travel through all of the interior of the earth. Second are the S waves. They will move the layers of the earth in a transverse kind of motion. Okay? So again, two types of body waves. These are the type of waves that travel through the interior of the earth. We have P waves and S waves. P waves, they compress the ground. S waves, they move in a transverse motion. Okay? Let's go to the second type. Let's go to the other types of surface waves. Again, surface waves only travel through the surface of the earth. This here is what we most feel during an earthquake. It is what causes the ground to shake even more. Body waves, they are very, very weak. They travel to the interior of the earth. And surface waves, these are the types of waves that we feel, the shaking that we feel. There are two types of surface waves. We have love waves, okay? Then we have Rayleigh waves. Some people say Rayleigh or Rayleigh, doesn't matter. Both of these waves come from the last names of the people that discovered them. So we have A.E.H. Love and then William Strutt Rayleigh who discovered surface waves. Now, let's go on to the difference. To the difference of these two kinds of surface waves. Okay? So, again, these two kinds of waves are the ones that travel through the surface of the earth. And the main difference that they have is the kind of movement that they do to the ground. Love waves, they move the waves in a horizontal type of motion. So, horizontal. So again, if you are on the ground, let's just use this one. If you are on the ground, you're on the ground, let's say this here, there's a building over here, you are over here. If you are going to experience love waves, the feeling is going to be side to side. Okay, side to side. Just like that. Imagine you're in a chair and then somebody is moving you from left to right. That is how love waves are going to feel like. And Rayleigh waves, on the other hand, is the rolling kind of motion. So, if love waves move you from left to right, Rayleigh waves move you in a rolling kind of motion, just like how an ocean wave rolls the water. So just like that, rolling kind of motion. So if you're standing and then an earthquake happens, it will feel like you're going up and then suddenly down, but in a rolling type of motion. Then you can say that Rayleigh waves have passed by you, or the Rayleigh waves are what you are currently experiencing right now. Now, a lot of students usually ask, so sir, what's the difference between S waves and Rayleigh waves? Okay, this here is the main difference. Number one, seismic waves are body waves. They travel through the interior of the earth. They travel to the mantle, right, and to other parts of the earth. And Rayleigh waves, they only travel through the surface. Another thing to take note is that Rayleigh waves are very, very strong compared to S waves. And the third difference is that S waves, they travel faster compared to Rayleigh waves. Because body waves are the fastest kinds of seismic waves to be detected by seismographs, so they're the fastest kinds to travel from the focus of an earthquake. And surface waves are the slowest kinds of seismic waves. So body waves first, and then surface waves. So sir, sino ang mas mabilis? Love waves or Rayleigh waves? They travel at the same time. Okay? So, you both experience love and Rayleigh waves at the same time. So sir, paano sila na-discover? This is how they were discovered. So both A.E.H. Love and Lord William Strutt Rayleigh, they were both scientists. And then they just mathematically predicted the different types of surface waves. Now, I cannot explain how they discovered that, but that is just the idea. Let's look at how you would both move the ground. So this here, again, P waves, they are compressional waves. They compress the ground. S waves, they move like this, transverse type of motion. And then this here is how Rayleigh waves move the ground. Okay, again, it's a good thing to take note. Rayleigh waves only are experienced at the surface of the earth. At the surface of the earth. Just like that. And love waves look like this. This is how love waves move the ground. Side to side motion. Side to side motion. Just like this. That's left to right kind of motion. And then this here is the Rayleigh waves. Rolling kind of motion. Just like how the ocean moves. Okay? And those are the different types of seismic waves. They all start from the focus of an earthquake. The focus on the earthquake is where the faults slip, the main source of energy. And we all know that energy travels in the form of waves, just like how my voice creates sound. Sound is the energy. And then sound travels in the form of sound waves. So the focus is the source of the energy, seismic energy. And it travels to the entire earth in the form of seismic waves. Seismic waves that travel through the interior of the earth are called body waves, and seismic waves that travel to the surface of the earth are called surface waves. And each type of waves has two kinds. There are two kinds of body waves. You have P waves, they're the first ones to travel. They're also called as compressional waves. And there are S waves, they're the second fastest kind of seismic waves. They're secondary waves. There are also transverse waves. And we have the slowest types of seismic waves to travel but are the strongest ones, surface waves. And then there are two kinds of surface waves. If you feel horizontal motion left to right, you are feeling love waves. If you are feeling like there's an up and down or rolling kind of motion, those are Rayleigh waves. And those guys are the different types of seismic waves.